Hello and welcome back to Daniel's Security Academy. Today with a new video about something network and network security focused, which is building an SD-WAN over an encrypted MPLS network. Can you actually build an SD-WAN infrastructure over an encrypted MPLS underlay? And does it make sense? This is pretty much the question we are going to ask today during the video, and I'm hoping to clarify both questions. Let's start with what is SD-WAN and why do you use it? SD-WAN is a new trendy marketing word in the past years, which is pretty much based on simple VPN side-to-side technologies. New to it is that everything is centralized and steered via a software-defined approach, moving traffic according to rules and performances on different WAN interfaces. For example, we have voice over IP traffic, which requires low latency. So you want to send it maybe over an MPLS line, which has low latency, but at the same time also low bandwidth on the MPLS line itself, because it just maybe has like 5 megabit symmetric. And on the other hand, you have maybe internet traffic, which is not too performance sensitive. So the traffic towards Google, Facebook, YouTube, whatever, it doesn't matter if it took you 50 milliseconds or 70 milliseconds maybe. So for those traffic, you can use just regular DSL cable cellular connections, which have a high bandwidth, but not like the performance of a low bandwidth, low latency and low jitter connection like MPLS, for example, has. So those DSL cable, cellular, whatever, do not guarantee some kind of performance, but they will give you a lot of bandwidth to work with. And this SD-WAN architecture enables to simplify enterprise networks and the WAN architecture itself, because you do disconnect the underlay from the overlay. So you can build an underlay however you want it, and you can build an overlay on top of it with your software. And it doesn't matter if you have changes in the underlay, the overlay will just adapt to it. So if you have like a truly dynamic overlay solution, it will just change maybe IP addresses on the WAN interfaces, but it will still apply the same rules as you have defined across the entire enterprise architecture or the enterprise network. And SD-WAN often introduces security features directly to the WAN. So yeah, there are still companies running without firewalls on the WAN. They might have a firewall at a central location, but the branch offices or whatever offices they have, smaller offices, they maybe connect to via VPN on maybe even a consumer grade hardware without any security features. But this kind of SD-WAN is both affordable and introduces security features to it. So SD-WAN is, apart from what I said in my first sentence, not just a trendy marketing word, but it also is a very good approach on modernizing enterprise networks, even though the technology behind it is a simple VPN connection, but handled via software. Moving on to the next part. What problem can occur when having an encrypted MPLS underlay? Because I said the setup is, should I run an SD-WAN infrastructure over an MPLS which is encrypted? So let's talk about the problems we can have in MPLS underlay. Or let's take it even a step back and talk first about why do enterprises even encrypt MPLS networks? So the MPLS network they buy from a carrier, for example, they the companies want to have full confidentiality. So they want to make sure that the carrier is not able to look into any kind of packets running between or on the MPLS lines. Therefore, they are running encrypted MPLS lines. However, on the same time, when we're introducing SD-WAN always relies also on encryption, which is on layer 3 via IPsec. So you would have double the encryption. If you introduce an SD-WAN project, we are running, as I just said, a double encryption on the line. We run the previously already existing MPLS encryption on the line itself to keep the carrier out of our communication and keep up the confidentiality. And on top, we are building again an overlay encryption, a VPN connection. So we do have double the encryption. And sometimes double the encryption does not mean double the security, and especially does not mean double the performance. So this leads to several problems we are having due to the double VPN overhead. Because the possible packet size, MTU, is decreasing, and therefore we have a shrinking size of TCP streams. So let's take it to an example, so it's maybe easier to get where I want to go. So we have an enterprise which is running at GetVPN. This is a very, very common Cisco proprietary function to run huge enterprise scalable encrypted connections on, for example, MPLS lines. And on top, we build our whatever SD-WAN solution. It doesn't matter if it's like also Cisco, if it's Meraki, if it's Fortinet, if it's whatever, Palo Alto. They all use VPN. So they also use the same technologies. So it applies for everyone. So the GetVPN itself uses an IPsec tunnel to connect pretty much both gateways or both routers, CE routers, with each other. And depending on the ciphers and settings used, it may lead to a maximum of 112 bytes of additional VPN overhead. So if you use, for example, AES-256 with GCM, if you use HMAC, if you use SHA, and if you use IPsec ESP instead of AH, so this can lead up to 112 bytes of VPN overhead for just one VPN tunnel. And if you run the VPN tunnel on SD-WAN as well, you have double the overhead, because you have another 112 bytes added to the overhead. So you're already on 224 bytes of overhead just because you're running a double VPN on the line. And we have to add also 4 more bytes because for the MPLS technology itself has 4 bytes for the identifier and the other header parts. So we are running 228 bytes as overhead on probably a standard MTU link of 1,500 bytes, meaning that we have 1,272 bytes remaining for our actual payload. And if you put this in a calculator, you will see that the performance or the maximum stream size you can run via TCP is decreasing significantly, because the packet size is just getting smaller and smaller. And so you have to send more packets on the line to send the same payload as before, because you are taking 228 bytes of overhead. So I will also link you a calculator, or the IPsec overhead calculator of Cisco in the video description. It is a very nice tool, an easy tool to use to calculate your very personal overhead of VPN, depending on the ciphers you're actually using, and will throw out the overhead and the actual packet size, which is pretty nice. But I do believe you will need a Cisco account to do it, so that it is behind the login wall. Moving to the next part, does it make sense to have encrypted MPLS in the underlay of an SD-WAN network? No, not at all. Encryption in SD-WAN setup gives you confidentiality against the underlay provider and also against the internet, because if you're using, for example, DSL links between location A and B, you will traverse the internet. But you're running an IPsec VPN connection, so you did your part on getting integrity and confidentiality on this connection. So you don't need to run another encryption on the maybe second WAN interface, which is running over the MPLS line. It doesn't make sense. You just probably pay an additional fee for the service of encryption on the MPLS line, and yeah, it just will decrease your performance for the packets on this line. The MPLS lines are usually expensive and small in bandwidth. Always bring a good set of performance with it, and probably also a good part of troubleshooting, reliability. You have a direct connect to the carrier. You don't have to go through the regular support hotline maybe, but it is not always better in latency and jitter. So I've seen already examples where a usual business connect DSL link was having a better latency and jitter than an MPLS link. So this one does not always hold true to the expectations you're gonna have on an MPLS line. So MPLS is not the god of everything. Let's talk about alternatives and the future trends. So if you're rolling out an SD-WAN project, make either use of a hybrid setup with unencrypted MPLS line plus a broadband connection over DSL cable cellular links, or actually get rid of the entire MPLS. You can run a very good network also without MPLS. And a good practice is to use two WAN links on different technology and maybe even different providers. So you have a full redundancy in the WAN. For example, you have a DSL link with one provider and cable link with another provider. This will add more reliability and more fault tolerance to the entire service on the location itself, compared if you have everything with one vendor with the same technology and the same connection type. Adding a 5G backup link, for example, might be also a good way to increase availability. So you could even add a third line. So if both lines fail because the cables were disconnected on the street because they were just digging up the street, you could add just a 5G cellular connection for backup purpose, which would kick in as long as your cables are being disconnected. This entirely is depending on how your requirements on availability is looking like. If you need a full availability all the time, you might want to have 3 links: DSL, MPLS or cable, and a cellular link. So you have multiple technologies and multiple ways actually to get into the internet. So over the air or via a cable in the street. And 5G in general can be a good and really reliable connection if you make use of 5G antennas. And I've seen very, very good results with using 5G as also a secondary or also a primary connection type for locations. Because if the antenna is placed well and you have a good coverage with the 5G, you will have an incredible speed at this very, very reasonable round trip times and latencies. So 5G is actually making a huge step towards reliability and usability for using it for workloads as well, for your work, for your office, not only for the consumer mobile phones, but also for you as enterprises. And it is most oftenly a very cost-efficient setup when you use 5G. Depending on how much you're going to pay for maybe an unlimited plan of 5G, it will most likely be still cheaper than running a business internet connect on DSL or cable, and especially probably just not even a quarter less, maybe 10% of the price you would pay for an MPLS line. So you can get in the money you are spending on the additional SD-WAN hardware and licenses and get it back from the underlay and save money from there. But as I said, it always requires a deep look into your business requirements. What is your requirement on availability? How do your offices look like? How are your contracts with carriers? All those play into a role on how to design your SD-WAN infrastructure. But as I said, it doesn't make sense if you're using MPLS to encrypt the MPLS itself as well. I want to give you a little future look out on what is going to happen in the next years. SD-WAN will keep growing year over year as this technology approach adds so much new value to networks while maintaining an overall cost or reducing the cost at the same quality or even increased quality. So in short, SD-WAN might be able to increase your quality and decrease your costs actually. But I cannot guarantee this because usually you're gonna pay an extra fee for the SD-WAN hardware and licenses, and on the other hand, may be able to reduce your underlay costs. They might break even, they might be higher costs even though you are reducing costs in underlay, but it also can be the way that you're actually saving money after all, because you are making use of very simple DSL cable cellular connections which do not have a high SLA to it, but you don't need it because you have the redundancy. You have the bandwidth to steer your traffic, you have the redundancy, you can use different technologies, different vendors, different carriers to have the availability you need at the price you can pay. And I think this is pretty much the summary I can give you about SD-WAN. Do not run it on an encrypted MPLS line, save money, and move over to DSL cable or cellular connections. And yeah, that's it for today's session already. As always, let me know what you think. Let me know what you think about the format. Let me know about the content I gave you today. And yeah, the more feedback I get, the better I can adapt for the future. So I highly appreciate any kind of comments, feedback, tips. And yeah, I hopefully gonna see you around in the next video. And until then, stay safe and take care. Bye-bye.